In the next few videos, I'd like to talk about machine learning system design. These videos will touch on the main issues that you may face when designing a complex machine learning system, and I'd like to try to give advice on how to strategize putting together a complex machine learning system. In case this next set of videos seems a little disjointed, that's because these videos will touch on a range of the different issues that you may come across when designing complex learning systems. And even though the next set of videos may seem somewhat less mathematical, I think that this material may turn out to be very useful and potentially huge time savers when you're building big machine learning systems. Concretely, I'd like to begin with the issue of prioritizing how to spend your time on what to work on, and I'll begin with an example on spam classification. Let's say you want to build a spam classifier. Here are a couple of examples of obvious spam and non-spam email, with the one on the left trying to sell things. And notice how spammers will sometimes deliberately misspell words like medicine with a 1 there, and mortgages. And on the right is a maybe obvious example of non-spam email, actually email from my younger brother. Let's say we have a labeled training set of some number of spam emails and some non-spam emails, denoted with labels y equals 1 or 0. How do we build a classifier using supervised learning to distinguish between spam and non-spam? In order to apply supervised learning, the first decision we must make is how do we want to represent X, that is the features of the email. Given the features X and the labels Y in our training set, we can then train a classifier, for example, using logistic regression. Here's one way to choose a set of features for our emails. We could come up with, say, a list of maybe 100 words that we think are indicative of whether email is spam or non-spam. For example, if a piece of email contains the word deal, maybe it's more likely to be spam. If it contains the word buy, maybe more likely to be spam. A word like discount, more likely to be spam. Whereas if a piece of email contains my name, Andrew, maybe that means the person actually knows who I am, and that might mean it's less likely to be spam. And maybe for some reason I think the word now may be indicative of non-spam because I get a lot of urgent emails, and so on, and maybe we choose 100 words or so. Given a piece of email, we can then take this piece of email and encode it into a feature vector as follows. I'm going to take my list of 100 words and sort them in alphabetical order, say. Doesn't have to be sorted, but here's my list of words, this count, and so on, and eventually I'll get down to now, and so on. And given a piece of email like that shown on the right, I'm going to check and see whether or not each of these words appears in the email, and then I'm going to define a feature vector X, where in this piece of email on the right, my name doesn't appear, so I'm going to put a 0 there. The word buy does appear, so I'm going to put a 1 there, and I'm just going to put ones or zeros. I'm going to put a 1 even though the word buy occurs twice. I'm not going to really count how many times the word occurs. The word deal appears, I'm going to put a 1 there. The word discount doesn't appear, at least not in this little short email, and so on. The word now does appear, and so on. So I put ones and zeros in this feature vector depending on whether or not a particular word appears. And in this example, my feature vector would have dimension 100 if I have a 100, if I chose 100 words to use for this representation. And each of my features xj will basically be 1 if a particular word, let me call this word j, appears in the email, and xj would be 0 otherwise. Okay. So that gives me a representation, a feature representation of a piece of email. By the way, even though I described this process as manually picking 100 words, in practice what's most commonly done is to look through a training set And in the training set, to pick the most frequently occurring N words, where N is usually between 10,000 and 50,000, and use those as your features. So rather than manually picking 100 words, you look through the training examples and pick the most frequently occurring words, like 10,000 to 50,000 words, and those form the features that you're going to use to represent your email for spam classification. Now, if you're building a spam classifier, one question that you may face is, what's the best use of your time in order to make your spam classifier have high accuracy or have low error? One natural inclination is to go and collect lots of data, right? And in fact, there's this tendency to think that, well, the more data we have, the better the algorithm will do. And in fact, in the email spam domain, there are actually pretty serious projects called honeypot projects, which create fake email addresses and try to get these fake email addresses into the hands of spammers and use that to try to collect tons of spam email and therefore get a lot of spam data to train learning algorithms on. But we've already seen in the previous sets of videos that getting lots of data will often help, but not all the time. But for most machine learning problems, there are a lot of other things you could usually imagine doing to improve performance. For spam, one thing you might think of is to develop more sophisticated features on the email, maybe based on the email routing information. And this would be information contained in the email header. So when spammers send email, very often they will try to obscure the origins of the email and maybe use fake email headers or send the email through very unusual sets of compute servers, through very unusual routes in order to get the spam to you. And some of this information will be reflected in the email header. And so one can imagine looking at the email headers and trying to develop more sophisticated features to capture this sort of email routing information to identify if something is spam. Something else you might consider doing is to look at the email message body, that is the email text, and try to develop more sophisticated features. For example, should the word discount and the word discounts be treated as the same word? Or should we have treat the words deal and dealer as the same word, maybe even though one is lowercase and one is capitalized in this example? Or do we want more complex features about punctuation because maybe spammers use exclamation marks a lot more? I don't know. And along the same lines, maybe we also want to develop more sophisticated algorithms to detect and maybe to correct deliberate misspellings like the mortgage, medicine, watches. Because spammers actually do this because if you have watches with a 4 in there, then, well, with the simple technique that we talked about just now, the spam classifier might not equate this as the same thing as the word watches, and so it may have a harder time realizing that something is spam with these deliberate misspellings, and this is why spammers do it. When working on the machine learning problem, very often you can brainstorm lists of different things to try like these. And by the way, I've actually worked on the spam problem myself for a while, and actually spent quite some time on it. And even though I kind of understand the spam problem, I actually know a bit about it, I would actually have a very hard time telling you of these 4 options, which is the best use of your time. So what happens, frankly, what happens far too often is that a research group or a product group will randomly fixate on one of these options. And sometimes that turns out not to be the most fruitful way to spend your time, depending on which of these options someone ends up randomly fixating on. By the way, in fact, if you even get to the stage where you brainstorm a list of different options to try, you're probably already ahead of the curve. Sadly, what most people do is, instead of trying to list out the options of things you might try, what far too many people do is wake up one morning and for some reason just have a weird gut feeling that, oh, let's have a huge honeypot project to go and collect tons more data, and for whatever strange reason just sort of wake up one morning and randomly fixate on one thing and just work on that for 6 months. But I think we can do better, and in particular what I'd like to do in the next video is tell you about the concept of error analysis and talk about a way where you can try to have a more systematic way to choose amongst the options of the many different things you may work on, and therefore be more likely to select what is actually a good way to spend your time, for the next few weeks or the next few days or the next few months.